Welcome back, dear friends. It's all getting terribly now. I keep saying fantastic in previous videos and exciting. I've got to think of some new adjectives. But it's time now to combine two of my favourite projects. The ukulele playing machine and Victoria the automaton. I never planned that they'd be combined. But once I'd got the ukulele playing machine actually playing when I'm cleaning windows, amongst other songs, dueling banjos I think, I thought, well, it really needs something else, some sort of accompaniment. In fact, that's why I chose When I'm Cleaning Windows, because it's such a classic ukulele song, played originally by George Formby. So I've got all the lyrics and stuff, and got Victoria out of her box that she'd been sitting in for 2 years whilst waiting the great resurrection, and now it's time to get her working. Let me show you what I am faced with. So here's the ukulele playing machine. As you can see, you can barely see the ukulele. It just grew and grew. It's so lovely designing, well, not designing actually, just designing as you go along some sort of ridiculously overcomplicated machine. But I've got it all working. I've got the plucking done with pluckers there. I've got the tuning, or the fretwork done with some little sliders with bearings on. Everything controlled by an Arduino Mega and all sorts of other things. First time, coincidentally, that I've used these big stepper motors opposed to the ditchy little ones that I usually use with their little intricate face boards. I'm using these huge ones to get the frets moving fast enough, and they're controlled by things that are even smaller. Beep, 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 that titchy little thing does all the logic to control one of these, and switching to control one of these huge stepper motors. So that's great. And then the second project, Victoria the automaton, who is looking to the right currently, or our left, because I tried to get all the servo motors that control her eyes working while she was singing along with this, and it all went a bit horribly wrong. Not enough electricity present, dear friends. So what I'm doing now is I was going to spend today sorting out and getting her servos and stepper motors connected up to the teensy, but in actual fact, don't ask me why, but I thought before I do that, I'd like to get this auto-tuning system working. And if you have watched the previous videos in this particular series, you'll know that I completely mullered up, ruined one of these little Spark Fun sound amplifier cards by trying to be clever and solder on a huge lump of brass, and it all went horribly wrong. Another one arrived, and this is where, once it plucks the strings, a little electret microphone fixed in there, now with an extra grub screw, so I can actually just push the wires in. It's one of those things, just think that would make life so much easier, and it has. So I've made the tube longer, so it now covers the signal wire and the ground wire from the electret microphone, and screens them all the way until they just reach this soundboard. And now I'm going to go and have some lunch, and then I'm going to go get the sketch going and see whether it picks up sufficiently the sound, the notes and the pitch and things to be able to calculate the frequency using something written by the person, Paul Sofragen, who designed and builds the teensy. He also wrote a library for the Arduino and other things to allow it to detect and read frequency. So we'll give that a go. That just screws beautifully in there. It doesn't stick up too high. And that little grub screw in the end just allowed me to poke the microphone in the end with its wires after I'd got all this lined up and fitted in. So that's lovely. I'm really pleased with that, because it took me hours before ruining things and mucking about, and then realising I'd got it fixed down, but the lid wouldn't fix on because it was standing proud of this, all sorts of stuff. So I'm very pleased with that. Now I'll get the Mega connected up and see whether it is actually still working. This end is doing something. One of the LEDs isn't working. I assume it's the LED because that tuning motor is turning. A little bit here, look, a little bit at a time. So let's see whether it finally stops, because it should be able to tell the difference between going up or down. Someone suggested in the comments that when you tune a guitar or something like this, you untune it first. You sort of loosen the strings by half a turn, and then you tune back up to it, which makes a lot of sense because it sort of takes out the slack. So I might actually do that rather than just starting off and trying to calculate whether to go up or down. Yes, Anyway, I'll get back to you if that does actually stop. It's the dreaded not a number. I remember having this before. Every so often it reads the right one. Because I haven't got any notes, of course, I'm not that intelligent. I've just looked back at the videos on YouTube and realised 3 things. 1, I had sorted it out and it made me very happy. 2, on the Spark Fun sound detector board, I had added a 10k resistor to lower the gain to 20 decibels rather than 40. And 3, get off, I had added built this circuit suggested by Paul Soffrigan, which is that circuit which helps to sort of change the waveform from analog sort of to digital, square wave or whatever. I am now going to put all this back together and try and recreate my past experiences. I've just tried it again, and look, it's got it to within 1 hertz, which is great. Very pleased. Right, I'll go set up with the other one. Then I'm just thinking about how to get the 2 tuning motors this side, and I was thinking about having these containers and all sorts of things, and I just thought, just sort of arranging it like I did with this bit originally, just thinking actually it would look rather nice to have the mirror, sort of mirror version of that cabinet here. Then it gives me an enclosure that I can then build stuff into, get things sorted out, but also just to keep it slightly simpler, because it's going to get too cluttered visually otherwise. It's so busy, which is lovely, but there is a limit, so I think I've reached it. And then I can just mount the 2 motors just like I did here, just into the side of the cabinet with the universal joints to link them up. I think I'm going to do that. So measurements, and then we'll get this frame made up. I'm going to make the new one in exactly the same way as I made the old one. Follow my finger. Zzz. Look, I've got the measurements. I did try and use Pythagoras' theorem. I got completely the wrong results. I did it on a proper calculator. Yes. So I've cut them all to the right length. Now what I'm doing, I've clamped them all, got them all square, because I'm just going to use butt joints at this end. And I'm going to arrange this piece very carefully on here, and then just use it as a guide. It's not pretty, but it'll do. There we are, scribbled there. Now I'm just going to go and hack away with the pencil and sanding machine to get these 2 angles correct. How many clamps can I use? Different types. Remembered I had these lovely ones, cast iron, that are perfect for clamping right angle corners, so that's good. Another one there, that's good. Got that all levelled up, and I've used a belt clamp, which they're so useful, these things. So you just put the belt round where you want and tighten it. And I've covered all the joints with bits of paper, so I don't actually glue the belt onto this or that onto that. Top tip there. Right, let's go and have some lunch. Look at that, if you will. That's come out a treat. And that's lovely. Having got this, I just marked out, drew around on a bit of ply, and then glued some nice little bits of beading around the edge, and that just fits on beautiful. Lovely. So, now to drill the 2 holes for the 2 stepper motors, these ones, to tune the tuning things on that side. Top tip. When you mark out and you've carefully calculated where you want the spindle to go, remember that your stepper motor spindle is not in the centre. Several hours later, having drilled the first holes in the wrong place and then realised, it's about kicking yourself, it's absolutely ridiculous. So I drilled the holes with the 32mm hole cutter first, realised I'd got them in the wrong place, then had to calculate and work out where the holes should be, then re-drill them. Then I've got huge holes now, I've got massive great slots into which I can't, there's not enough room for them to support any sort of fixings. So, what to do? Well, as always, the laser cutter came to the rescue. Here's a nice plate, mounting for the two motors, which hopefully will line up with all the other holes and everything else. I'll get that sprayed up and try it. Oh, it's so annoying. How ridiculous is that? Forgetting that these aren't in the middle. Oh, so close, yet so far. Luckily though, I've got one of these broken. One of these broke, these stepper motors. And I took the front off, so that's a perfect template to be able to mark everything out, hopefully. Fingers crossed. I'm going to spray this up brass, as always, take the dog for a walk, and then we'll try it and see whether it all fits together. Actually, it's not right at all. Well, it sort of is right. It's a comparative, isn't it, really? Not good enough, so I'm going to use this and now tweak them. Thankfully, I haven't deleted the drawing yet. It's several, I have to say, enjoyable hours later, and I've finally got it done. I don't even know whether they're in the right place, to be honest with you, because it has got so confusing. In the end, I didn't bother with the... Oh, well, I did use the second one, but I had to drill out all the holes to make it fit. And I mean, look at the state of the inside of it. Oh, electric jigsaws, drill bits, all sorts of stuff. But hopefully they are in the right place, so I can now get that mounted and then make the linkages to link them to the tuning things, like on the other side. It's another day. I was just thinking about making some more of the reciprocating chronometer kits, because I think I made 10 to start with, because I didn't know whether they would be popular, but they were, and they all sold out. And I haven't got around to making all the bits to some more, but so I checked. I haven't got any 10mm acrylic. I haven't got any brass filament, 3D filament. I haven't got this, I haven't got that, I haven't got the other. I think I might need to do some shopping first. However, having said that, we've got the two Pringlers made up and sprayed. So that's nice to tune with, and we've got the beautiful polished cabinet. Beep, beep, beep. Which does look beautiful and polished. In fact, it outshines this one. I think I must have mixed the stain better. That's a bit embarrassing. Now, interesting, isn't it? Aesthetics. Because there's the window that shows you the little flickering LEDs on the, there we are, on the interfaces for these two tuning motors, this side. And I've got a similar one to go on this side, and I've been mucking around thinking, should it go there a bit like the other one? Should it be in line? And for some reason, I think it's going to look nice there. Isn't that weird? Weirdly interesting. Anyway, lovely copper pipe to move wires from this side to this side. Motors in place, fixed down. Things made up. Time to get on with it. Right, so the middle line is the output from the microphone, the analogue, and that's the output, DC output from the filter. Let's try the first note. Well, hang on a minute. It does seem to work remarkably well. Right, the next note. Well, that's nice and clear, isn't it? You can see it turning into a square wave. That's nice. Dog taken for a walk. In fact, 2 walks because it's the next day. It's amazing taking the dog for a walk. It just allows you to clarify things. So I've clarified it, the tuning. What I'm going to do is I'm going to have the option to manually tune it. I'm going to have a tone generator, which makes perfect sense, because then I can tune them by hand by pressing an up and down button and some other levers and bits and pieces, which is also very exciting. And the addition of another horn, or a horn actually, this machine hasn't got one yet, to amplify the sound from the tone generator. And that means that I don't think the frequency of each string will vary that much. Obviously, as it gets warm and cool, it might vary a little bit, but it means that I'll then, on the automatic tuning, just ignore any frequency that's outside a sort of specific range. So forget double the frequency or any of the harmonics or whatever. It's just going to look at the little centre bit of gap around the frequency that we want and just work within that. I think that's going to make it so much easier. I came to tell myself, obviously this is a very enjoyable project. Having spent months building to plan lots of other things, I've got to get back into the mindset of just really enjoying coming up with the most ridiculous way of doing things. So, let me show you what I've done. What a horrible noise, I hear you cry, but who cares? It's a square wave. I did look up, that's a horrible noise actually, hang on. I did look up how to generate sine waves using Arduino. It's really complicated, obviously. I don't mind, because there's a tone function which you just give it 3 values. You give it the pin you want to connect the output to, the frequency you want, and how long you want the frequency to play. It couldn't be simpler. And then a 100 ohm resistor and a piezoelectric sounder, and that's it. So I'll start with that. Obviously you could use a system of resistors and capacitors to sort of turn the square wave into a nice sine wave, but I'm going to start with that, and then we'll go, because there are ways of using digital to analog converters and all sorts of libraries and everything else. It's not necessary. There comes a time in every machine's life when you just think, no, this is the limit. And I found, luckily, this piece of paper which has got the notes that I need for this particular tune and the frequencies, which is handy, Harry. Right, let's get on. Here's a lovely old signal generator. At the moment it's 1000 Hertz. Oops. And it's a sine wave which looks like that. You can hear it sounds quite nice and smooth. If I turn it, however, onto a triangular wave, that's not so pleasant. And if I turn it onto a square wave, that's even less pleasant. It's like there's a higher pitch and more edge to it. More an edge to it or something? I don't know. Anyway, I thank you. That's the difference. But they're all the same frequency. It's just the shape of the waveform. After a fair degree of cogitation, rumination and whatever else, I've come up with a plan. I need some sort of control switch knob thing to go to play, when it'll just play the tune, or manual tune, A, E, C, G, and auto tune that will do all 4, and an up and down button. So bearing that in mind, and a very brief sketch later, because I was thinking out all sorts of ways of creating a knob, I thought what I'd do this time, which I haven't really done before, is to use a potentiometer, a variable resistor, a linear one, so it adds resistance equally all the way round, not a logarithmic one. And that way I can use the output from this, connect the outer 2 pins to plus 5 volts and 0 volts, and the middle pin on the wiper can go straight to one of the analog inputs on the Mega in here. So, oh, that's heavy. So it's not going to take up another load of connections and things, and it'll give me insufficient control, because then with an analog input, depending on where this is turned, I can just have the varying voltage, you sort of split up. If it's between this voltage and that voltage, do that, or if it's between that and that. So it'll have sort of hysteresis, a nice big gap and things, or whatever. It won't actually, I'm talking absolute pretentious rubbish, but hopefully it'll be far apart enough to be able to easily see things, and if it isn't, it'll just add to the wild fun. I've got a wooden knob, I'm going to use that. Now, I need to work out how to arrange all this. I found from the Pi Hut, I've just ordered 2 illuminated pinball buttons, push buttons, which are great. I used them in the first machine, the big one I made, and they looked a bit like organ stops. They weren't here, but I had flickering LEDs in each one. They did look beautiful, so I'm going to do that again. Oh, and also decided, where's it gone? Hang on a minute. A horn to amplify the piezoelectric sounder. Let's just plug that in and make that beautiful square wave. Now, if I put a horn on that, it sort of makes it louder, but it looks nice. But unfortunately, these horns, let's switch that hideous noise off. These horns, which are the ones I use for the NetNet Throbwells and things, they're very, very well made, but, I don't know whether you can see that, they have a big sort of stamped logo inside. I want something to enable me to hear that tuning pitch. Focus. So, because I did think about having a horn stuck out the top, which would look nice, but for practical terms, that's sending all the sound away, and I'm going to obviously be standing somewhere close to be listening to the tuning, to be able to manually tune it. So I'm going to have one that sticks out here facing forward, which again I did use in that big steam pump machine, and which looked really nice, a bit like a sort of earpiece. So I can't use this one because it's very difficult to sound this plastic. I can use one of the hideous cheap Chinese copies. Obviously the company that make this, they actually have the patent. They invented the sounder for this, and as always some Chinese company somewhere decided to do their own copy. Really badly made, hideous, they don't work properly, the horn is all bent. It's, look at this, look at that. I mean, I've sprayed it obviously, but that is just a blemish on the injection moulding. It's dreadful. But I have to say they did get the inside nice, so I'm going to use that horn against this piezoelectric thing. Now, how to arrange all these controls, all the knobs and the push buttons and labels? Well, back to the computer. No, I haven't used this really for the music machine because, as you know, I've just been planning it as I go along, but there comes a time in every project when it's pretty useful to be able to actually sort of plan things out. So I've imported the thing lens holder from the barometric prognosticator because I want a lens over this. This is how I'm going to control it. Wooden knob in the middle. Let's make that bigger. Bigger? Well, wooden knob in the middle, an engraved disc with the 6 different settings nicely written around, lens over the top, not saying exterior reading. So as you turn this, it can then magnify and show you which thing you're doing. The 2 buttons to manually tune up and down. So I'm just fiddling around, which is most enjoyable, working out how to get this looking nice. Another great day in paradise, and the sun is shining. I've just taken the dog for a walk, hence the sweat. I just came into from taking the dog for a walk, picked up the mail, the delivery and stuff, and amazingly I ordered the switches, the push buttons, as I think I mentioned, from the Pie Hut yesterday afternoon, and then sent them an email saying, could you possibly let me know the diameter of the hole to drill that the switches, the buttons push through. And would you believe it, Adam and Eve, this very morrow, they've arrived. That's good news, lovely. Everything's just held in with prongs. Here's the switch, bendable prongs. Here's a switch, and it looks like you could get this white insert out to be able to put some sort of legend in there if you wanted to. So that's good, and that pops out and leaves you with access to the switch. And a beautiful little thing with 2 surface mount LEDs on that just sits around the switch. So I've popped that out as well. And I found, thank goodness, that I have got some flickering LEDs around. Luckily, a 5mm diameter standard LED will just, its legs will push through the 2 holes where the little LED board came from. It'll happily sit there without getting in the way of everything. I was just trying to cut out the gear. First time I've ever, very excitingly, used engraving laminate to make a gear from. Pushing the boundaries. There's the function knob. Just come out beautifully. I just glued it on with super glue, of course, and there's little brass ferrule, I think they're called, that I made to fix it onto the shaft. So that's going to go in there. Then I've got that gear which I'm going to spray up and put a bearing in the middle that goes in there. I painted the 2 knobs. Isn't that exciting? So that's the black underneath to stop the light coming through, and the brass on the top. So they're going to fit through there and there, with that somewhere over here with a lens to magnify the particular function you're after. So it's all coming together. I've got to reassemble the bits for the switches. Brilliant. I'll get back to you when I've got this assembled. And here we have one of the switches completed. I've glued an LED, the flickering one that I'd coloured black so that the light could only go out of the lens, in there. Look, isn't that lovely? That gives a beautiful effect, and the button works perfectly, and that just flickering really does look like it's got some sort of incandescent illumination in, so I'm really pleased with that. So those switches were from the Pie Hut, and painting this black and then painting it the brass colour really has worked well. There's no light leaking through that from the LED. Very pleased with that. Oh, I do like a flickering lamp. Right, let's get all those screwed down then.